we're going to talk about building ChatGPT Data Pipeline. And as such, too, it's a complicated subject matter in a sense because it's new, right? And then we're all everywhere. As we know, ChatGPT came out just a year ago on November 30th, right? 3.5, and it's kind of shocked so to speak, right? Kind of make shock the world. And everybody is going after it, is taking center stage. So, okay, so here we are. Let me kind of start, but very quickly too, who are we, right? So quick intro of the speakers, and I'll have Karin introduce herself.
Sure. I mean, I feel like he did a great job introducing us, but basically I do developer relations consultancy. That's basically, I don't know, it's a bunch of different things for like developer community related things. I came from a entertainment background. Prior to working in tech, I worked in rap music, which is like a natural progression. I feel like going from rap music into technology. It's kind of an odd story on how I got here to this journey, but I've been working with software developers and like very data centric technologies for years, and I absolutely love it. And me and Mary have worked on talks before, even though we work at different companies. We have always found our ways together, and I love it.
That's right. Yeah. So thank you. Yeah, it's Karin's idea. Said let's do another talk. So here we are again. So and again, I won't spend much time now. It's such we only have very short time, right? Doing this half hour, less than half hour, and trying to pack everything in. But you can take a look at the screen and see who I am, and then we'll be sharing our contact information towards the end of our presentation too. Okay, so let me kind of start too. Let's first, give everybody, I mean, presumably this is an OSACon, so open source analytics, so perhaps not as much talking about AI. So I feel it will do everybody some justice to kind of talk a bit too about GenAI, ChatGPT, what it is, right? And then what is leading us into developing this talk. And we feel excited about it. And just a lot of things going to be packed in. So I'm going to, let's be very fast and step through ChatGPT a little bit deeper than what we see in all the publications now. So, but I think first of all, too, even for me, like AI is not, something I've worked too deeply with. I did some work too when I was at IBM, and a bit more on unsupervised actually is a reinforcement learning. But now getting a chance at DataStax, we're all about generative AI now, and and also with the vector database that we have. So I feel, myself too, I wanted to really go deep into understanding first, what it is that we're trying to do. But if you kind of think too, ChatGPT, all of these things are essentially about automation. Automation, so then it's making us human beings like less concerned with a lot of tedious things. I think we should look at it that way and not something that will take our jobs away. But let's kind of very quickly, right, peel the onion, understand it on a high level. There's AI, artificial intelligence, which essentially is mimic the intelligence or behavior pattern of human beings, of any other living entity. And so if you kind of peel the onion, it gets into like machine learning. So machine learning is a technique by which a computer can learn from the data without us kind of actively training. But we kind of give the data and say kind of like, here you go, computer, think, start thinking, process and everything. But then if we kind of get deeper too, we do need that cognitive kind of capability of really diving into how human beings think. And that's where deep learning comes in, right? This is where, as maybe some of you have heard of, right, all of the LLMs, all of these NLPs, like natural language processing, which I'll kind of quickly touch on kind of shortly, is essentially gets into the neural networks and really giving the magic of this whole thing. So what is GenAI, right? It's just really fast, and to kind of talk about it, I would describe it as a disruptive field in AI. So it's a potential to change the way we create and consume contents. And also, too, essentially, it generates new contents based on prompts. So these prompts, that basically you have to make sure you ask the right questions in order to get what you're trying to look for, too. So it's combination of the machine learning and deep learning to produce contents. And it tends to be more on the creative side, as we have all already been fascinated by it, right? We're kind of asking it, can you write a poem? Can you design a dress? Can you write a piece of music? All these things are generative AI versus like predictive AI, which came before this. And predictive is dealing a bit more with maybe looking at business forecasts, weather forecasts, something that, what is kind of generated will have a time limit to it. So then it expire after 5 years, you do a forecast, for example. So quickly too, again, ChatGPT, GPT stands for Generative Pre-trained Transformer. So it takes simple prompts, right, in natural human language, and that's what is kind of earth-shattering at this point, because it takes like how we talk, like you and I, we talk as input and ask the bot to do work for us. It does a lot of pattern matching, answers questions for the prompts, and produce, again, contents like writing a new essay, blog post, and a new computer program. And let's kind of really quickly, too, again, look into NLP, right? Natural language processing that's involved is an interdisciplinary subfield of linguistics of computer science. So the concern is to try to process these natural language data sets, right? And it used like rule-based, like probabilistic machine learning kind of approaches. And that's what is essentially what LLMs, large language models, are kind of using this capability behind the scenes. So what is LLMs, right? These are what kind of, if you're kind of into GenAI space, this is what everybody, developers, engineers are kind of working directly with, the large language models. It's a type of machine learning model. It takes a lot of money to produce, right, as we know, and it performs essentially NLP tasks too, generates and classifies text and answer questions based on your prompts. Okay, so these are just some examples of the API if you're interested, right? LangChain, Llama 2, these are just a handful of, kind of more popular ones that you can work with, like Hugging Face is more of an open source thing. Okay, so here we are. So after kind of giving you an introduction, let's kind of go into RisingWave 2, and let's see what we're kind of trying to look, right? We're kind of looking into the point of view of building data pipeline. So data, right, is really at the heart of AI. So we'll have Karin kind of give us an introduction, and then we'll then get into the demo next.
Okay, I might have to have you walk me through the clicks, right? Okay, so first I'm just going to go over the basics. What is stream processing? This assumes you understand streaming technology. You can click once.
Sure.
So stream processing is a data processing approach that deals with continuously flowing streaming data. As you're bringing the data in, that is when you are doing your queries and your transformations and your processing. The data is literally in motion before it's even stored inside of a database, which gives you the ability to do it as real time as possible. So it does give you the ability to do real-time analytics, transformation, and then computation of the data as you're bringing it in, which gives you the capability of doing anything, a lot of things in near real-time capabilities. Like you haven't even stored the data yet, and you're making transformations on it. So just to dig into like the types of kind of queries that you can do in stream processing, and these are the types of things, but like there are a lot of areas that you could be kind of creative with it as well. And I would recommend for you to like look into more stream processing capabilities. But just as a high level, you have the ability to do filtering, which involves a selection of specific data from a stream based on predefined conditions. The example here, I included an example of each one just because like sometimes it's kind of unclear on how it can apply in real life. So this is like filtering out log entries that contain errors for immediate attention. Another one is aggregation, which involves summarizing or reducing data over a certain time window or key. So calculating the average temperature over the last 10 minutes from a sensor stream. You can keep going. Joining streams. This is one of my favorites, just because I just think it's cool and interesting. And I didn't really know you could do this until I dived into stream processing. But you have the ability to combine data from multiple streams, so different type of streaming data based on a common key and condition, and then be able to query those results. So that's like combining user click data with product data to analyze user behavior. I think this is one. You can do dozens of streams, which is pretty cool. You can continue. Windowing. This allows you to query groups data into fixed time intervals or windows for analysis, like analyzing total sales for each hour of the day over a week. Pattern recognition, identify specific sequences or patterns of the event in the data stream. So detecting a series of login failures as a security breach attempt. This is like a lot of the anomaly detection kind of stuff falls into this as well. And stateful processing is maintain state information to analyze data over time, such as tracking user sessions So monitoring user behavior and detecting when a user session is idle, which is obviously very important because it happens frequently. And then, so that's like kind of the basic understanding of what is stream processing. Now, going into what RisingWave is an open source distributed database that's basically SQL for stream processing. So you could basically do stream processing using SQL. So it's designed to reduce the complexity and cost of building real-time applications. So as I mentioned, stream processing, very real-time, kind of as real-time as you can really get. So basically what it does is it gives you the ability to consume the streaming data, multiple streams if you want, and then it performs incremental computations when the new data comes in, and then it updates the results dynamically. It also is, as I mentioned, it's a database as well. So it has the ability to do the downstream side, the storage side. If you choose, you don't have to do it that way. You can have the downstream in another, to go into another database, but it does offer you that capability as well if you want like access, quick access to that data that you just processed and did queries on. So it maintains its own storage that allows you to access the data efficiently. Built-in Rust, I added this in because I just think it's cool and people like it. So it makes it very, very performant and very fast. SQL-based, this is really fun. It is all in SQL. So if you know SQL, you can figure out stream processing. The learning curve is not insane, which is really nice, and it's Postgres compatible. And another benefit, storage and computation are separated, so you can scale them out independently as well. So that's what RisingWave is. Oh, also incremental updates on materialized views. That's another big one that people seem to utilize quite frequently. So just to talk about just kind of a recap of what is RisingWave, it allows you to bring in data from a variety of sources, Amazon S3, Pulsar, Kafka, Kinesis, whatever. Then you're able to ingest it in real time as the data is coming in before it's actually stored. You can join streams, you can do filtering, aggregations, transformations, as I mentioned before. You have the ability to continuously update the data and queryable states. And then you also have the ability to have the downstream where you can store it in database, warehouses, message queues, or in RisingWave database as well. Yeah, so I think that's, and then, on the very left-hand side is all the streaming side of things, of like log, event-driven capabilities. Yeah, okay, you can go on to the next. You can actually click these bullet points in.
Okay.
Okay, so it includes these key components. So the first one is a serving layer. It's basically parses SQL queries and then performs the planning and optimizations of query jobs. Which is, I feel like it's kind of self-explanatory why this is important. Then you have a processing layer, which performs all the computation, like the actual queries that you are doing. And then you have a metadata management service, which manages the metadata of different nodes and coordinates operations amongst these nodes. And then the last is the storage layer, which stores to and retrieves data from object stores like S3. I feel like that was like a long-winded answer. I feel like I'm like blah 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 blah. If it sounds like blah 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 blah, I'm sorry. You can just put it on mute. Okay, so some examples of RisingWave use cases. You can click on the first one. One is streaming ETL, the practice of continuously extracting, transforming, and moving data among different systems as the data moves in. You have the ability to, do the ETL, put it into a database, or you can actually bring it back into a stream if you want. But the streaming ETL is one example. Go ahead, next. Real-time analytics. I'm assuming most people are pretty familiar with this practice. The practice of analyzing data as it's generated and received rather than after the fact. One thing to keep in mind about real-time analytics is that you also have the capabilities of providing your end users with, like the users of your applications, with real-time insights to take action on. And that's also something that's very good for user happiness. I don't know what that's, there's a term for it, but I don't know what it is. Doesn't matter. And then you have event-driven applications, which enables continuous event ingestion and processing, detecting complex patterns and correlation within a stream of events. Then we have another one. I thought I had
Oh,
okay. Oh, good. That's good. It's good. So
that's good.
I'm gonna go into this really quick, just because we for lack of time, like whatever. There is a link to the documentation. You could probably type in fast Twitter events processing RisingWave on Google, and you can find the documentation page of this. But this is a couple screenshots from this use case example. But basically, it's just allowing you to do hashtag kind of analysis. You can click.
Oh, sorry. Okay.
I'm just, like I said, I'm going to go through this really quick. I'm not even going to give you guys a chance to really process this. No pun intended. If we were using RisingWave, it would have been processed. You get it? Okay, it doesn't matter. Okay, that's bad joke. Bad joke. If you think it's funny, raise your hand. I thought it was funny. Okay, so the first thing is you launch the demo cluster. Go ahead. You can click next. There is some missing pieces here too. I didn't screenshot the entire documentation page. If you want to see everything, click on the link, or just Google it. Then you're going to connect RisingWave to the data streams, kind of as I mentioned before, where the data is coming from. Go ahead. Then you define a materialized view. It has incremental updates of materialized views, and then give you the ability to analyze the data. And the next one. And then finally, you can query the results. So this is like an example for being able to analyze and process Twitter hashtags as they come in. I think it covers it. I'm going to hand it over to you, Mary.
Okay, great. Okay, so as such, right, we kind of short time. So I wanted to introduce to you, like I said, we are kind of more like experimenting with this idea because of all these toolings that are out there, and we can use all these tooling to build data pipelines that make sense, right? So we kind of look into this Twitter feed, and we thought of an example of, making essentially using the right tool for the right job and really maximizing the use of each tool. So you can think of like, okay, we have a Twitter feed, using RisingWave, and then it will quickly kind of locate certain tags, right, that you find, in the feed. So then what to do, right? We get into a ChatGPT type of scenario. So that's where DataStax Astra DB Vector can also come into play. But let me really quickly then go over the vector database. What is DataStax, right? So vector database is purpose-built. So as such, right, DataStax, we have Astra or Apache Cassandra that's powering our managed cloud platform called Astra. So that's essentially Cassandra underneath the hood. And so we have added in vector capability to handle like multi-dimensional data for generative AI type of machine learning purpose. So as such, it's a purpose-built database, right, that it serves up these vector data type. So these data type, you can think of it. Why is it necessary? And that's because of the fact that we're dealing with machine learning. We need to be worrying about data that's multidimensional. So that's kind of like leveraging on vector math. If you're a math person, I bet you're familiar with linear algebra, all of these matrices. How do you deal with the math? And that's what it is built upon on. And essentially, too, it relies on vector embeddings, right, to help with all of these computations too. And essentially, vector embeddings are what you translate or your data. Let's say a string that comes in, you do need to parse your data, and then each string will get converted to some numerical representation. So as a result, when you store data like this, if you kind of do a select, you see that the table will contain data that's made up of arrays of floating point numbers in there. So that's what it is. These are vector databases making use of all these techniques, and it's really a form of machine learning feature engineering too. And also too, the technique it uses to try to, when you go to query, is essentially using, Cassandra is using the approximate nearest neighbor, this technique to kind of do, and these are really fast search too. Okay, so what are then vector embeddings being used for, right? It's basically used for searches. So you can think of, as such, right? We're kind of going back to LLMs, large language models. They are very restrictive, right? They are, they're large slab of data, so to speak, right? Huge, humongous, and the thing is, though, it has a, it's so big, right? That body of data, and it doesn't actually have any storage. It's very static. So you're relying on, a vector, a data store to help it store data outside of the LLM. And so you can kind of essentially use, vector embeddings and vector database to help you with similarity type of searches, and also like clustering and for example, recommendations. If you're doing ordering goods and the shopping cart, you can kind of think of it using it for recommendations, and also anomaly detection, diversity measurement, and classification. So these are kind of uses of vector embeddings, kind of multiple uses because of its capability of searching through multi-dimensional data. So really kind of quickly showing to you in pictorial form, right? What is a vector embedding? If you take a look into these data, they're kind of looking at them like two-dimensional kind of normalized vectors. As such, right, vector is essentially not just like a magnitude, right, of your data. It's really about the magnitude of the direction. So it adds more information to the data at hand, right? So essentially too, without going into kind of a lot of kind of deep detail, but just kind of this is what you can kind of think of. These are vector kind of embeddings. That's how they are being stored. And essentially the embedding model to transform the text into the vector called embedding. And it can be like however many dimensions. But right now, if it is with OpenAI, the embeddings are 1,536 dimensions. There's still a limit to it. But version 2 will have more, and then version 3 have even more too. So kind of like an example here too is to show you if you have cat and dog, how they are being stored in this two-dimensional kind of vector space too. So really quickly, again, like vector stores and vector databases, you kind of, it provides like embeddings storage, right, with or without metadata, depending on the database too. So these built-in algorithms are very fast, helping with fast retrieval, kind of doing these nearest neighbor type of searches too. And it is really a new type of data that's supported in these established databases, such as like DataStax. We have Astra DB, Cassandra, and also a new like kind of specialized databases such as like Pinecone and Milvius. Okay, so really quick kind of thing is to talk about traditional database you can kind of use to store multidimensional kind of data, but then it will make the query, the storage kind of much harder and also takes more time. And so typical, like kind of going back to, right, how does it kind of work with data pipeline? But typically too, that's what you would do, right? You would read data from a source, such as like Kafka topic or S3 bucket or something. Then you process the data to extract this text to vectorize it, and then split this text into chunks of a given size, and then compute all of these vector embeddings for each chunk, and then rewrite the chunk to the vector database. Then you will clean up obsolete data from the vector database. So this is kind of like the kind of operational things that you can think of that will kind of be making use of a vector database. Okay, so now that's kind of next thing is we kind of just talk about building this ChatGPT data pipeline, and have to kind of say too, because of the time, we actually did not get to have it work yet, but then as such too, if we kind of bring together like a RisingWave and a data stacks kind of scenario, how can we kind of build, right? Build like an example. So if you kind of take a look too into like AI and today's world, the AI is dealing with training phase and then inference. Inference is when you apply the model to kind of do similarity searches. So this is where we're thinking is a prompt that comes in, right? You can be like having a Twitter feed, and RisingWave strength is to kind of identify, do an analytics on searching through, for example, searching for tags, for example. Then you can use that and build a prompt, and then with that, then you pass on to DataStax our Astra DB vector to help you with chat completion and that type of stuff to search for the answer. So this is kind of like a really quick diagram that describe a Twitter feed. RisingWave will kind of help you sort through and then kind of massage, so to speak, get all the tags out, and then we can then massage it and essentially to have the tags essentially like, send it to another Kafka, for example, topic that can actually be absorbed into the DataStax data pipeline, and then let the Astra DB vector do its job to kind of vectorize all your data and doing all the searches that's needed. Okay, so this is kind of another kind of diagram, maybe a little bit kind of too much for this talk, but I just thought it might be interested to kind of show it to you, a vector database, where it stands, in this generative AI type of application, can be for ChatGPT, a ChatGPT kind of data pipeline too. Okay, so I think then with the time that we have left, I won't have any more information on this talk for now. And how about Karin, do you have anything to add, or before we go into the resources?
No. No, I had somebody who asked a question. I'm just working on writing the answer to the question.
Okay, yeah.
Um,
All right,
but
yeah.
no, there is a bunch of like resources online. But I'm gonna respond to the question. He basically asked about the difference between Kafka, Flink, and RisingWave and where they all kind of fit together. So,
Sure. Yeah. Okay.
but
Okay.
I'll go into that in the questions.
Okay, yeah, we can all have more discussion at the Q&A room, right, or afterwards too. So yeah, but for now, let's share this. This slide deck can be accessed here. This is the short link, bit.ly link, and also the QR code here. And also some data stacks resources about our vector search too, and the Cassandra, and also our Astra data stacks is our managed cloud platform. You can sign up and get the free tier, $25 per month of usages and $300 a year, so you can continue to get that too. And also this one, oh good, yeah, the RisingWave, yeah, thank you. That comes from Karin.
Yeah, I mean, I just kind of kept it simple. I'm like, honestly, you go to the risingwave.com website. You can go scroll down to the bottom. You can join the Slack. There's a docs page. You could find everything there,
Thank you.
And also, I'm in the Slack. If you have additional questions, like you can message me on the RisingWave Slack. That's probably the easiest way. But you can also Google my name, and it's like, I feel like me and Mary, like our names are probably pretty unique. There's probably not another Mary Grygleski, right?
I know. That's right. Yeah.
Right.
Okay. Yeah. And this one again, with our Astra platform, the vector search, if you are interested today, I don't have time to give it, but maybe in the Q&A room, if folks, if you want to see, I can show it there too. But this is how you can sign up for it. And also I have my Twitch stream too. And this is how you can follow me on Twitch. I promise you I'll be doing more actually hands-on demo too.